So the only, you see, to be able to basically work with this encryption, I decided to extract bytes because I think it may be an alternative to work with characters, which are Unicode characters. But I could have used individual characters maybe, but I decided to use bytes. So the actual encryption happens here. Right, so what I do is that I go and I say I have this array of characters, right? Array of characters here, an array of characters. And so forth, right? And then another array of characters that I have, I use it as a key. So what I do is that I take this character, which may be J, like Joe right here, Joe. Those are individual characters, and then my encryption key is like secret, right? So this is secret, which is my encryption key. Okay. So what happens is that I take this character, and then what I do with them is that I say J, and I use this exclusive OR operator to combine these two characters. The result of this combination, I store back the result of this. So let me get rid of these quotes or anything. We'll just say we take two characters here and we combine them together, and the result is stored right back, right? So when we run the application, you can see that the result of me doing this is that character J, uppercase J right here, combined with lowercase s, yields a decimal value of 57. So the properties of this operator, which is one of the bitwise operators that are available. This is called exclusive OR operator. This operator right here, the exclusive OR. This operator right here sits in heart of all encryption algorithms. So this is how it works. So for example, if we have a exclusive OR operation is defined as it takes two inputs, A and B, and then the result is an exclusive OR. So A and B internally at the bit level can be all possible combinations can be 0, 0, 0, 1, 1, 0, and 1, 1. So the exclusive OR operation is defined as follows. As long as those inputs A and B are different, which is not the case with 0, 0 or 1, 1. As long as they are different, exclusive OR gives you 1. If at the same time they're the same, the output of exclusive OR is 0. Okay, and so this is done for all bits. For example, if J, arbitrarily is like 1, 0, 1, 0, 1, 1, 0, or something like that, and then lowercase s is 1, 1, 1, 0, 0, 1, 1, arbitrarily, right? So the exclusive OR operator, this operator, is applied on every bit, and the result goes to bit. The result is also a bit by bit result. So every bit is combined based on this definition of exclusive OR, and its result becomes like 0, 1 becomes 1, 1 1 becomes 0, 1 0 becomes 1, 0 0 becomes 0, and so forth. So it's very simple type of operation. It's extremely fast because CPU can do this directly. The CPU has this operation built in as one of the instructions, right? But an interesting outcome of this is if B is the key, that interesting observation here, and let me just try to give you an example. An interesting observation of this is that when you take exclusive OR result and combine it with B again, right? So let's just move B from here to this column and say we want to apply this B again, right? Notice the following: 0 and 0 gives me 0, 1 and 1 gives me 0, 1 and 0 gives me 1 because we still continue using exclusive OR, and 0 and 1 gives me 1. That's A, okay? So this is how combining an input with key and using exclusive OR operation and recording it, but then if you take the result of exclusive OR and apply the key again symmetrically, you actually get back an A. And so this is in heart of any encryption algorithm, and in our case, what was happening is that because we say this is a symmetric operation, like encrypt, decrypt, the same B was used as a key, right? So 0 and 0, 0 and 1, 1 and 0, and 1 and 1, we're producing 0, 1, 1, 0 in this order. So then we took the B and applied it again, and then the result of 0, 0, 1, 1, 1, 0, and 1, 0 was this. And you can observe from the definition of exclusive OR operation that this column is identical to this column. So therefore, exclusive OR can be used like this symmetrically to encrypt and decrypt values. And you can see that in our code, when we went to main, we used one key, then we used another key, and we could use other keys. As long as you know what the key is, you can both encrypt and decrypt, right? So of course, more practical ways to encrypt and decrypt data is to use asymmetric key like public and private keys, but this simple demo code demonstrates how you can encrypt and decrypt using just plain CPU operator or instruction exclusive OR, which is written as the caret sign right there.